Hey Cubs, welcome back. In this video, we're going to go over a couple of the practice problems from the Predicting Product Practice Worksheet, which can be found under Topics on Mudge. Um, it's hyperlinked within the calendar, but you can also find it on the left-hand side with the other resources. Before attempting these Predicting Product Practice Worksheets, make sure that you had a chance to view the lecture notes, my video, the video from Mr. Mahan, and then also the Chapter 8, Section 2 review help video. You're also going to want to have your Predicting Products reference sheet handy as we go through some of these products. So let's go ahead and start in on, let's take a look at number 2 to begin with. So 2 gives us NaI sodium iodide plus calcium chloride to begin. And it doesn't give us the products, but that's okay because we can use the products, we can use these reactants here to predict the products that we have. So first, let's identify what we have on the reactant side. We have AX plus BY. So anytime you have two compounds that are not water and hydrocarbon, it's going to be a double displacement reaction. So if you go to the Predicting Products worksheet, you can see for double displacement reactions, AX plus BY yields AY plus BX. So remember, cations replace cations and anions replace anions. So what we're going to have here is the outer A and Y combine and the inner B and X combine. So you might be wondering, well, why do I write B first? Well, that's because B is a cation. Remember, when we write chemical formulas, we want to make sure that the cation goes first. So A in this case is sodium, plus 1. X in this case is I minus 1. Calcium is our B. Calcium has a 2 plus charge. And chlorine, Cl1 minus, because we're looking at the ions here. So now we want to recombine these. So A sodium plus Y chlorine. So sodium has a plus 1 charge, chlorine has a 1 minus charge. Sorry, it's auto-focusing. Give it a second. There we go. So when these combine, we end up with Na1Cl1, and then clean it up, NaCl. So what we're doing here is we're predicting the products. In step 1, we want to make sure that we are writing down the correct chemical formula. It's okay if they're not balanced right now. We'll balance after we properly predict the product. So B is calcium. Calcium is a 2 plus charge. X, we wrote down, has a minus 1 charge. So I minus 1. Then when we do our switcheroo, we end up with Ca1I2, and we're going to clean that up to get CaI2. Remember, we don't need to write this 1 subscript here. It's understood to be there. So now that we have our proper chemical formulas for a product, we can go back and start to balance the equation. So NaI plus CaCl2 gives us NaCl plus CaI2. So we have sodium, iodine, calcium, chlorine, sodium, iodine, calcium, chlorine. So right now on both sides we have 1 sodium, we have 2 iodines and only 1 iodine. So we can't change what's inside of this chemical formula. We can't add a subscript. What we can do is add a coefficient here. So if we add a 2 coefficient, that now brings our iodines to 2. Now, anytime you add a coefficient, make sure that your other elements are still balanced. So we have to go back and change the sodium to a 2. And then we need to place a 2 in front of our sodium chloride on the product side so that we have 2 sodiums on that side. Then taking a look at calcium, we have 1 calcium, 1 calcium, and we have 2 iodines, 2 chlorines on the reactant side, and 2 chlorines on the product side. So now we have our balanced chemical equation. So that's 2NaI plus 1 mole of calcium chloride react to produce 2 moles of sodium chloride and 1 mole of calcium iodide. Now we also need to identify the type of reaction here. We said we had compound plus compound, compound plus compound. If it's not combustion, that means it is double displacement. So box or circle your answer there. Okay, let's take a look at another one. Let's take a look at number 5. So number 5 on the worksheet, if we scroll down, is AgNO2 silver nitrite plus barium sulfate. Okay, so step 1, we want to see what type of reaction we have. Well, we have a compound plus a compound. That means it's going to be a double displacement. So for double displacement, if you refer to your quick reference sheet, double displacement, we have AX plus BY yields AY plus BX. So we set that up, AX plus BY. Now we want to combine the outer, A and Y. A gets written first because it's the cation, plus BX. B gets written first because that's the cation as well. So A is Ag with a +1 charge. X is nitrite, the 1 minus charge. Recall your polyatomics. If you need to go back and review those from the previous chapter, please do so. B is barium, 2+, and sulfate with a 2 minus. So I'm writing these out in this way, so when we go to combine them over here, I know what ions are being combined, which will help me write down the correct chemical formula. So A is Ag plus 1, Y was sulfate. We do the switcheroo, clean it up, Ag2SO4. And then B is barium with a 2+ charge. X is nitrite. We do the switcheroo. Now notice we kept the parentheses here because the subscript outside of the parentheses is a 2. We dropped the parentheses for sulfate because the number outside of the parentheses was a 1. So it would be redundant to have that. So now our formula is AgNO2 plus BaSO4 react to produce silver sulfate and barium nitrite. Okay, so now that we've predicted the products, now we go back and balance the equation. Predict the products, write them correctly, doing the switcheroo, then balance the equation. So we have silver, we have nitrite, barium, and sulfate. Silver, nitrite, barium, and sulfate. Okay, let's start with silvers. On the right side, we have 2 silvers. On the left side right now, we only have 1 silver. But we cannot add a subscript. We can only change the coefficient. So if we change this coefficient to a 2, that means the 2 gets distributed to silver, and we have 2 silvers. Now if we take a look at nitrate, I like to keep polyatomics together when I can, just to help simplify the balancing process. So we have 2 units of nitrate on the reactant side, and we have 2 units of nitrate on the product side. Sorry, nitrite, not nitrate. Barium on the left-hand side, we have 1 unit of barium. On the right-hand side, the product side, we also have 1 unit of barium. Sulfate, 1 on the left-hand side. Sulfate, 1 unit of sulfate on the right-hand side. So when these all match, we have a balanced chemical equation. So our answer will be 2 moles of silver nitrite plus 1 mole of barium sulfate react to produce 1 mole of silver sulfate and 1 mole of barium nitrite. Now this type of reaction will be a double displacement reaction. Whoops, having trouble spelling there. Double displacement. So the reason why it's called a double displacement reaction is because two different units are being displaced or replaced. Now let's take a look at a single replacement reaction. So we'll use this side. Okay, if we take a look at number 10. Number 10 on the worksheet. 10 on the worksheet has lithium, let me scroll down, lithium nitrate combining with silver. Okay, so anytime you have a compound plus a solo element, that's going to be a single replacement reaction. So for this single replacement reaction, we have AX plus B, where B replaces the A to give us BX and A. So this is going to be a single replacement reaction. A is lithium with a +1 charge. X is nitrate, the -1 charge. Silver has a +1 charge. Give it a second to focus. Come on, hovercam, there we go. Okay, so B was silver, so Ag +1. X was nitrate, NO3 -1. And A was lithium, +1. So when we do our switcheroo, we end up with AgNO3. No need for the parentheses because the 1 would be outside the parentheses, so there's no need for it there. And then lithium is written as +1 here. But recall that metals can exist by themselves in these compounds. So it's just Li, no charge on it. So when we rewrite it, we have LiNO3 plus Ag yields AgNO3 plus Li. So now that we've properly written the products, we can go back and balance the equation. Once again, I like to keep those polyatomics together, so we'll write nitrate. Okay, lithium, 1 on each side. Nitrate, 1 unit. Nitrate, 1 unit. And then silver, 1, silver, 1. So they balance out. We have LiNO3 plus Ag gives us silver nitrate plus lithium. Then the type of reaction, anytime you have one element in a compound, most likely that's going to be a single replacement or displacement. You can write it either way. Let's take a look at one more here. We have let's go with number 12. Why not? Okay, 12 right here. We have carbonic acid, H2CO3. So when you start with one substance as your reactant, it's probably going to be a decomposition reaction. And it's an acid, so it decomposes into the nonmetallic oxide and water. So taking a look at H2CO3, what is it going to decompose into? Well, we just learned on that quick reference sheet that acids decompose into a nonmetallic oxide and water. So then we go about balancing the equation. HCO, HCO. Notice I broke up this polyatomic here because it doesn't appear on both sides of the equation. So that is a case where you do want to break up a polyatomic, is if it doesn't appear on both sides of the equation. So hydrogen, we got 2 and 2, carbon 1, oxygen 3, oxygen 2, plus 1. 2 plus 1 is 3. So we have a balanced chemical equation there. So our answer will be H2, 1 molecule or mole of carbonic acid decomposes into 1 mole of carbon dioxide and 1 mole of water. When you start with one substance, you have a decomposition. And there's our answer there. So let's just briefly talk about the predicting products reference sheet. So synthesis reactions. Synthesis, you start with two separate units to get one unit as a product. Decomposition, if you start with just one compound, it's probably going to be a decomposition reaction. Single replacement, if you start with one element and a compound, it's probably single replacement. Double displacement, if you start with two compounds, notice these are all two compounds. If you start with two compounds, it's probably a double displacement reaction. And then combustion, if you have a hydrocarbon plus oxygen, that's going to be a combustion reaction. Your products will always be carbon dioxide and water for those combustion reactions. So let's write that down. So synthesis, usually two elements for the reactants. Usually, not always. Sometimes you can combine, but for this class, it's usually going to be two elements for the reactants. Decomposition. Usually one compound for the reactant, and that is usually going to be a decomposition reaction. Single displacement. That's usually going to be one element plus one compound for the reactant. Then double displacement or double replacement. I use those interchangeably. That's fine. This is usually going to be two compounds for the reactant. So those two compounds, we're going to split up AX plus BY to give us the AY plus BX. And then lastly, combustion. So combustion, usually going to be, instead of usually, it's pretty much always. The only exception for this class is going to be hydrogen, but that can also be considered a synthesis reaction. But it's a hydrocarbon plus oxygen gas as the reactants, and the products are always going to be carbon dioxide and water. So use this as a brief template to quickly be able to identify the type of reaction that you're working with. Look at the reactants. Use this. Use your quick reference guide. That's about it for now. Let me know if you guys have any questions using the email, discussion board, or Remind. And I'll see you later, Cubs. Have a good day.